Welcome back to KMI Community Connect. This is again an interlude before we do Metabolism Made Easy Part 11. So I'm again one more time our job here trying to explain to you about how we are trying to connect the dots. We've connected a little bit about diabetes, which is high sugar, hypertension, which is high blood pressure, fat, which we called as obesity, and I can also list one more in the fat that we measure in the blood, which is the high triglycerides, which is actually the energy of the fat form, the energy in the fat form, triglycerides. And we also call loosely the other parts of the fat making, which is the cholesterol. So I am going to expand this cholesterol here. I'm going to expand all this, what we measure in the blood in the form of fat, high blood pressure, diabetes, which are all a reflection of a one pathway which we talked about, which I mentioned here, which is insulin. Insulin is a hormone that's made in the pancreas here that I listed here. That's an organ that's giving signals to every part of the body, including the brain, heart, kidney, muscle, liver, and fat tissue, and the reflections of that function are measured when it is a dysfunction in the form of diabetes, high blood pressure, obesity, triglycerides in the blood, and all that. So first thing first, how to understand these principles and we can try to connect is I want to bring this concept before I do the next part of Metabolism Made Easy Part 11 about insulin. So insulin is a hormone, and hormones are nothing but they are messenger molecules, which are actually protein molecules which are folded, and they are actually telling and giving a signal to the body and to the cells in the tissues. Every cell is in different parts of the tissues here in the kidney, in the heart. These are all tissues, and it cells, as it tells the cells, the insulin tells the cells what to do with the energy. So insulin is the primary hormone that brings in glucose, what we talked about glucose here, and tells the cells what to do with that energy, and those cells are present in all the tissues all over the body. So, and in turn the cells are actually looking for the signal from the hormone which is insulin. So like that, all the hormones are actually doing something to give a signal. If insulin is giving a signal for the energy, other hormones like testosterone, which is a sex hormone, estrogen, which is a sex hormone, they are all actually giving signals to the cells, and the cells are looking for the signals from those hormones, insulin being one today that we are talking about. And that they are actually waiting for that signal, what to do with that signal. So the most important thing that I'm going to talk about today, trying to connect these dots, is actually how to bring in the concept of sensitivity of that hormone. If your hormone is very sensitive, then you don't have to do much production, your body doesn't have to make too much. Whereas if your hormone is if your body is very resistant to the action of the hormone, then your body has to make more of that hormone until it works. So imagine like this: if you are very sensitive to what I say, I don't have to shout in your ears. I just have to say very little and then you can hear. But if you cannot hear, I keep raising my voice and shouting louder and louder for you to hear, and your cells need more and more of that shouting as I keep doing this for you to hear. So your body tries more and more to compensate for the same amount of action. Another example I can give you, like let's say you have a subway station train, 100 people are coming down the escalator, and the compartment of the train can hold only 50 people, and when 100 people come in, stay on the platform, only 50 people can enter into the compartment, and 50 people, they remained on the platform and they cannot enter and the doors close and the train leaves. 100 more people come down the stairs and now there are 150 people waiting on the platform. 50 more people only can get into the compartment of the train. The doors close again and the train leaves. So you have a pile up of 50 people every time the train leaves, and then the compartment gets flooded. So when that happens, there is a system where the body tries to push more and more into the train by putting extra energy, and that's what the insulin does. It thinks that there is a pile up of energy, just like how it is happening on the platform, the pile up of energy in the blood, because the cells don't want to take anything more and they keep pushing back. Just a cell, you can imagine like a train compartment. So when that happens, so insulin, what it is doing is, if this is a glucose, if let's say if this is a cell, and if this is the door of the cell, there's a door here, and insulin is trying to bring in glucose. Let's pile up these glucose molecules like this, one glucose molecule, one glucose molecule, one glucose molecule. It's trying to line them up and try to send them into the cell. And I will mark insulin, the hormone that's trying to bring this in and trying to push this in towards the cell. And when the glucose goes into the cell, there is only so much that can go into the mitochondria to become energy, and that becomes energy. And when that is done, when more goes in, it converts it into fat, like what I said. It can only convert it into fat, either inside the cell, or it brings it out and puts it into a separate fat tissue and converts it into fat for future usage. So all this glucose can become fat with the help of insulin, because that's for future. So when this happens, the very nature of the hormone or any insulin is, if there's more energy going this way and the body cannot take any more, and the cell will try to either push it out into the blood. This is blood, what we are talking about, this is all blood. It puts it back in the system. When that happens, then the insulin that comes from the pancreas, to recall the memory, this is pancreas. When there's more glucose accumulation here, the pancreas will start making more, thinking that this has to be pushed back into the cell. And so it's like more and more and more and more and more of backup of glucose in the blood will lead to more and more and more and more and more of insulin for the same effect. So that is what is called as insulin resistance, the analogy I gave. So the body makes more for the more glucose that is accumulating, and as this continues in the vicious cycle, at some point the body, the cells stop responding and there's a pile up of everything, and this process is called insulin resistance. I will explain this to you more. You need to understand this before we proceed to the resistance, the typical resistance, what it means. Now, how does that manifest? That manifests in various ways, either high sugar, high blood pressure, high cholesterol, high triglycerides, increased weight, because this resistance that we are talking about is not necessarily just related to the sugars. It is related to everything that we talked about in terms of what we were saying, either fat, blood pressure, glucose, triglycerides, which is energy that we talked about, cholesterol, and fat again is the weight. Now, the tricky part is not everybody presents with the same thing. Some people with insulin resistance will just have high blood pressure. Some will have a combination of high blood pressure and fat, which is weight gain. Some will have high glucose and high triglycerides. There's a lot of ethnic and racial variation. Some will have skin changes. Some will have headaches. Some will have menstrual irregularities and not having regular periods. So everything is from excess energy and the resistance to that energy to be put into the cell, leading to what we call as insulin resistance. I will explain this again and again more in detail while we touch base and go more in detail into the topics of how this insulin resistance presents differently in different cells, and we give different names. Basically, what you and I and all of us have to connect the dots and remember is whatever we measure in terms of blood pressure, sugar, high triglycerides, cholesterol, weight, all these are a manifestation of underlying lack of effect of the action of insulin, which is called resistance, which means the cells are not able to be accepting the signal that is coming from the insulin, and the cells are becoming resistant to the action of insulin. That means the sensitivity is coming down and cells are becoming more resistant, and the manifestations of those of excess energy are all what we measure as high blood pressure, high sugar, high triglycerides, weight gain and all. So this is the same mechanism, and also the other mechanism, which is the starvation signal, which does not go through insulin resistance directly, even though they are kind of connected but different, is the mechanism that we talked about all this time. So there are two pathways. One is a direct insulin resistance signal, the other one is a starvation signal, which causes fat, which in turn again causes insulin resistance indirectly. So I'll go more in detail in deep, because uric acid comes into the other signal, which is not a direct signal that causes insulin resistance, whereas the simple glucose with more energy causes the insulin resistance directly. So one is indirect, which is the uric acid comes from fructose. The other one is a direct signal that comes from glucose causing insulin resistance. With this background, I'm going to see you again on Metabolism ADC part 11 to talk more in detail about, first I'll start with high blood pressure, that's very important, and then we'll go into other details. Thank you very much.